Hello everyone, I hope you all are good and solving lots of questions. Let us solve one with me. And for that, let us read the question first. So there is a point A that moves uniformly with velocity v so that the vector v is continually aimed at point B. Okay? So A is always pointing towards B, uh, which in turn moves rectilinearly and uniformly with velocity u less than v. So B is moving rectilinearly. It is not headed always towards A. B has its own line of motion. Let's say B has this line of motion. So it will keep moving towards this line, but A will move in such a way that it is always headed towards B. ठीक है so and there is one more information given at the initial moment of time v is perpendicular to u v u से perpendicular है and the points are separated by distance l how soon will the points converge means at what time they will meet so suppose कर लो initially तुम्हारा a यहाँ है and b is here ठीक है so initially you are given their velocities are perpendicular to each other so a has to be in this direction ठीक है and b has to be in this direction done it and what is their initial separation that is l over course of time a and b will move such that b will always move along this line but a will move making sure its velocity vector is always headed towards b ठीक है सो लेट्स ड्रॉ इट्स ट्रेजेक्टरी इन रफ सेंस अगर t इक्वल टू 0 टाइम पे तुम्हें ऐसा कुछ दिख रहा है जो भी डायग्राम है देन लेटर ऑन व्हाट इट विल लुक लाइक सपोज कर लो कोई भी अदर टाइम पे B has moved here. So A will go somewhere, right? So if B is here, A let's say is here, such that its velocity vector ये हमेशा उसकी तरफ पॉइंट करना चाहिए अब देखो उसके लिए B को मुझे थोड़ा डिफरेंट बनाना पड़ेगा बिकॉज इट डजंट लुक लाइक कि अभी वो क्या है A जो है वो B की तरफ हेडेड है सो B इस लाइन पे लाई करना चाहिए तो B कुछ यहाँ होगा अब सपोज कर लो A तुम्हारा यहाँ आ गया तो B should be headed towards this such that their velocity vector will be always perpendicular to each other. So it will go like this, B will go like this. Done it? So if you make their trajectory, ये तो straight line पे जाएगा और ये कुछ ऐसे जाएगा. Done it? So let's now talk about how we can go with the calculation. Suppose कर लो कोई भी instant पे किसी भी time t पे मैंने A को यहाँ पे रखा और B को यहाँ पे रखा. ठीक है? So I mean A का जो velocity vector तुम्हें दिख रहा है that is pointed towards what? That is pointed towards B. You can see here. So this is the line of velocity vector of A. So it is this line. V का line ये है, U का line ये है. Done it? So if you talk about how their separation is changing, initially their separation was L, and at this time, at any time t, their separation you can see as this one. Okay? And finally, when they will meet somewhere, let's say they are meeting somewhere here, so they both will be here, right? So when they are meeting, separation between them will become what? Zero. डन है सो एट एनी टाइम टी अगर हम इस सेपरेशन के बारे में बात करें एट एनी टाइम टी आई एम सेइंग लेट्स से दिस सेपरेशन इज समथिंग एक्स लेट्स से इट इज एक्स ठीक है सो हाउ यू कैन डिफाइन दिस रेट ऑफ चेंज ऑफ द सेपरेशन इज डिक्रीजिंग सो रेट को पॉजिटिव बनाने के लिए आई हैव गिवन नेगेटिव साइन सो माइनस डी एक्स बाई डी टी कैन बी रिटन एज व्हाट वेलोसिटी ऑफ ए टुवर्ड्स बी right so velocity of I mean relative velocity of A with respect to B so velocity of A with respect to B will be how much so B की speed u है इस direction में how much will be the value of B's velocity along this line it will be u cos theta done it so what is the net velocity of A towards B it has inherently v velocity but b is also moving away with a speed u cos theta so with what net velocity a is approaching b so you will say v minus u cos theta right and this is this so minus dx को आप क्या लिखोगे आप लिखोगे v minus u cos theta dt ठीक है and you will change it like this so separation will change from where to where l to 0 right so this will come as how much this will come as l and v is constant u is constant but theta is not constant because as a will approach b their velocity vector of a will make different angle with the horizontal ठीक है so theta is not constant इसको आप ऐसे solve कर लो v dt minus u को constant लो cos थीटा dt। ठीक है, सो वी हैव टू डील विद दिस। अब देखो सपोज कर लो t टाइम तक वो पहुंच जाता है, सो l विल बी इक्वल टू vt माइनस u cos theta dt। we cannot reach to the solution, है ना, थीटा को लिखना बहुत ही कॉम्प्लेक्स है, so we can think of writing some other equation also, and what can be that। अब आप एक चीज ध्यान से सोचो, जब ये पार्टिकल मीट किया है किसी भी रैंडम पॉइंट पे, मैंने बोला यहाँ मीट किया सपोज कर लो, सो इन दिस टाइम how much horizontal distance a has b has covered? This much. And how much horizontal distance a has covered? This much. Both has covered same horizontal distance। ठीक है, so horizontally अगर आप देखो सपोज कर लो in t time they are meeting, so horizontally this distance is equal to according to b how much? ut, because b is moving along this line with speed u, so this distance is equal to ut। अगर आप a की बात करो तो a has a different velocity along the x axis वाला direction at different amount of time। So at this particular instant for which we have calculated minus dx by dt, क्योंकि जनरल लिखना पड़ेगा a के लिए, सो a के लिए अगर आप कैलकुलेट करना चाहते हो, देन एट दिस पॉइंट ऑफ टाइम इट हैज हाउ मच वेलोसिटी इन द x डायरेक्शन v cos थीटा। ठीक है, सो डिस्टेंस कवर्ड यू कैन राइट एज व्हाट? v cos थीटा dt, इंटीग्रेटिंग फ्रॉम टाइम 0 से t, है ना। we need to differentiate I mean we need to it at this instant in this small time, suppose कर लो ये टाइम था तुम्हारा t, and स्मॉल इंक्रीमेंट टू दिस टाइम, सपोज कर लो डेल्टा टी तुमने इसमें ऐड किया, तो इन डेल्टा टी अमाउंट ऑफ टाइम हाउ मच डिस्टेंस इट विल कवर हॉरिजेंटली? v cos theta dt, that is delta t, because that delta t is very small, so in that very small time we can say that whatever is the status of velocity vector of a at time t will be same as that of at time t plus dt, because dt is very small। so इतना small है कि a के change को हम neglect कर सकते हैं, then we can see कि in time dt it has covered how much distance along the x axis? v cos theta dt, done it। and if you will sum it starting from time t equal to 0 to time t equal to capital T, you will be getting this distance, and this distance is equal to how much? ut। so we can equate it like this। अब आप इसको equate करके check कर लो, ut equal to v cos थीटा dt 0 से t। अब आप देखो 0 से t cos थीटा dt को आप क्या लिख सकते हो? सो 0 से t cos थीटा dt को आप लिख सकते हो ut बाई v। अब इसको ये इक्वेशन 2 ले लो, एंड फर्स्ट वन वाज इक्वेशन 1। इक्वेशन 1 में cos थीटा dt का वैल्यू 0 से t तक इसको पुट कर दो, कितना वैल्यू आया है हमारा? ut बाई v। सो पुट इट हियर, अगर आप उसको पुट करते हो कितना मिलेगा? So L is equal to Vt minus U into Ut by V, right? So how much value we are getting? L equal to V square minus U square T divided by how much? Divided by this is V, right? So T equal to how much? LV by V square minus U square। अब देखो why it was given that V is greater than U, अभी इसको आप अप्रिसिएट कर सकते हो, क्योंकि हमारा टाइम क्या आया है? हमारा टाइम आया LV divided by V square minus U square। Time can never be negative, but ये वाला term अगर negative हो सकता है if V is less than U। So if V is less than U, you will be getting time tending to negative, and time can never be negative। So if you are getting negative, it has a simple meaning that they are meeting never, done it। So if V is less than U, they will never meet, and in the question it was given that U is less than V, that is V is greater than U, and in that case you will be getting positive time, it means they are meeting somewhere। ठीक है, now if you want to appreciate this question more, suppose करो question में ये दिया रहता कि A was there at this instant, A is here, B is here। in the question it was given that velocity of A was this, velocity of B was this, done perpendicular to each other, and if in the question it is given that A will always point towards B and B will always be perpendicular to, and velocity vector of A will be always perpendicular to B। सपोज करो इस क्वेश्चन में हम ट्विस्ट ला रहे कि A velocity vector of A is pointed towards B, but in such a way that velocity vector of A is always staying perpendicular to B, then how you would have drawn the trajectory? डन है? कह क्या रहा है कि ये दोनों के velocity vector, that is VA always has to be perpendicular to BB, that is V has to be perpendicular to U always. So what motion should look like? कैसा मोशन होना चाहिए बताओ? So if V is always perpendicular to U such that A is also always pointed towards A, तो इस चीज को देखो अप्रिसिएट करने के लिए मैंने यहाँ पे डायग्राम बनाया है. सपोज कर लो ये तुम्हारा A है और ये तुम्हारा B है. सो इनिशियली A एंड B का वेलोसिटी एक दूसरे से क्या है? परपेंडिकुलर है. डन है. सो आफ्टर सम टाइम B विल रीच हियर, सो इट्स वेलोसिटी विल बी दिस सेंस. अगर तुम्हारा A सेकंड जो तुम्हें नॉर्मल दिख रहा है ना, ये वाला रेडियस लाइन है, ये भी एक रेडियल लाइन है. अगर इस रेडियल लाइन पे यहाँ पहुंच गया है तो इट्स वेलो और थर्ड पे पहुंचा है यहाँ पे, सो इट्स वेलोसिटी विल बी इन दिस डायरेक्शन एट दिस पॉइंट एंड इन दिस डायरेक्शन मीनिंग इट इज पॉइंटेड टुवर्ड्स बी such that its velocity is always perpendicular to A. So in that case, point A will slowly rise on all the radial lines. ठीक है? So it will move something like this. और ये इसको ऐसे मीट करेगा. ठीक है? ये रेडियस पे डिफरेंट डिफरेंट रेडियल लाइंस पे चलेगा. ठीक है? एंड फाइनली इट विल मीट बी समवेयर हियर. डन है? क्लियर है? And how you will calculate here the time? Here, since velocity of B is perpendicular to A, so always perpendicular, so B has no component towards the A, and A is always headed towards B. It means whatever velocity of A is, that is towards B. So if initial separation between A and B is equal to the radius, that will be, I mean initially L है, तो L radius के सर्कल के डिफरेंट डिफरेंट रेडियल लाइंस पे वो चलेगा. So initial separation is L and time taken will be equal to L by velocity of A simply. Done it? So this way you could have solved this question. In इस question में क्या था? A was headed towards B, B not headed towards A, but such that VA is always perpendicular to BB. So you can think of many different things here. And this topic is really interesting. It will really broaden your imagination power and it will really add something to your mechanics. So keep on solving such sort of question. I hope you have understood. Even if not, you can always let me know in the comment section. Thank you.